Hello, this is Mr. Miller. Hope you're doing well. And this is video 6D. In this exciting video, we're going to talk about compound inequalities. All right, let's do this. So compound inequalities are when we put together two or more inequalities with an and or an or statement. So for instance, in this first one, we want to graph all the values of x that are greater than -5 and less than or equal to 2. We need both of these to be true. So and kind of means both. Values of x that are greater than -5 and less than or equal to 2. Well, while we're learning to do this, it's kind of useful to graph both inequalities separately and then graph the final inequality. So we're going to graph x is less than or greater than -5. So I'm going to do that on the top one here. That would be a hollow dot here. And greater than -5 would be to the right. X less than or equal to 2, that's the other inequality. And so I'm going to put a solid dot at 2 and an arrow to the left. Both of those are called simple inequalities. And now we're going to make a compound inequality that's made from both of those. So we want all the values of x that are on both graphs. Well, I see that starts to happen here at -5. In fact, -5 is on the second graph, but not the first graph. I'm going to put a hollow dot there. But everything to the right of -5, at least till we get to 2, is on the graph. So I'm going to draw my graph up to 2. 2 is on both graphs, so I'm going to put a solid dot there, and I'm going to stop. All right, so this little piece right here, that's the part that belongs to both graphs. Kind of starts at -5, but doesn't include -5, and goes up to 2 and includes 2 because 2 is on both graphs. Over here on the right of 2, yeah, we have values on the first graph, but there are no values on the second graph. All right, let's try this one. So x greater than or equal to 0. I'm going to put a solid dot here and go to the right. X is less than 4, so on the second graph, I'm going to put a hollow dot and go to the left. Kind of makes sense to copy the dots. Here, 0 is on both graphs. 4 is only on the first graph, but not the second, so I'll put a hollow dot there. And just by looking at it, I can tell the values of x that are on both graphs are in between those. So that's the graph of the compound inequality. All right, one more. X is greater than -3. So let's go this way. The second inequality is x is greater than 1. All right, they're being tricky this time. So x is greater than 1. We want the values of x that are on both graphs. So if I look, that doesn't happen until after x equals 1, till about right here, right? That's where we start getting values that are on both graphs. So I'm going to put a hollow dot at 1 because 1 is belongs to the first graph but not the second one. And I'm going to draw an arrow to the right. So my last graph represents those values that belong to both graphs. Okay. Takes a little getting used to. All right, now we're going to switch to inequalities with the word or. Okay, so or means all the values of x that belong to either of the graphs. It could belong to one of them, the other one, or to both. Any value of x that's on either graph. It's kind of like putting the graphs together. I think this one's a little bit easier for us. So we got x is less than or equal to -2. So I'll put a solid dot there, go to the left. We have x is greater than 4, so hollow dot going there. And we want a graph that includes every value of x that's on either graph. So we want to include these values of x from the first graph. And we want to include these values of x from the second graph. It's kind of like just putting the graphs together. That's what we get. There's all the values of x that are less than or equal to -2 or greater than 4. All right, on this one, x is less than -1, so hollow dot and to the left. X is greater than 2, hollow that to the right. This is OR, so we want all the values of x that are on either graph. So we're going to put them together like this. These come from the first graph. These come from the second graph. There we go. Okay, this one's a little bit trickier. X is less than or equal to 3. Okay, and x is less than or equal to 5. So we want all the points that are on either graph. Well, it turns out that the first graph is kind of included in the second graph. So if I want all values of x that belong to either graph, if I look at it, I just have to copy the second graph. All right, that includes all the values of x that are in either of the graphs. Okay, so usually we're not going to give you 3 graphs to do. That's kind of while you're getting used to this and thinking about and or. Normally they're going to look like this. So we want values of x that are greater than or equal to -2. Okay, so I'm just going to start drawing that. It's going to be a solid dot at -2. It's going to go to the right. And x less than 7. Remember, and means both. So less than 7 is that way. So I want greater than or equal to -2, but also less than 7. It's everything in between these. All right, this is kind of a shorthand way of writing an and. This means x is greater than -4 and x is less than 5. Kind of means x is in between these values, right? So let's put, first one's x is greater than -4, so let's put a hollow dot there, and it's going to go to the right. X is less than 5, we're going to put a hollow dot there, and it's going to go to the left. We want everything in between, so we're going to connect those two. All right, the last one's an OR. Okay, pretty much we just have to graph both the inequalities. X is less than or equal to 1. So we want all those values of x. And we want the values of x that are greater than or equal to 6. So this is a graph of all the values of x that satisfy x is less than or equal to 1 or x is greater than or equal to 6. Every value I mark satisfies at least one of them. Okay. All right. So here is the last thing we're going to talk about. We're going to do 2 examples like this. So sometimes we have to solve the inequalities before we can graph them. So we want the values of x that satisfy this first inequality and the second inequality. We want values of x that satisfy both of them. Okay, so I'm just going to go about solving them. I have 3x plus 10 is less than or equal to 28. If I subtract 10 from both sides, we get 3x is less than or equal to 18. If I divide by 3, I get x is less than or equal to 6. No flip because I divided by a positive number. All right. On the other one, we have 9 plus 5x is greater than or equal to -36. I'm going to subtract 9 from both sides. So that makes it -45. And I'm going to divide by 5. I get -9. No flip because I divided by a positive 5. So we need values of x that are less than or equal to 6, going that way, or actually and greater than or equal to -9, which is about there. So the values of x that are in between them. Any value of x that's greater than or equal to -9 or less than or equal to 6, and less than or equal to 6 would satisfy both of those. All right, you can do it. It's just putting it all together. All right, one last example. This one features the word or. Pretty much we have to solve them and graph both of them. So m plus 2 is greater than or equal to 9. So if I subtract 2, I get m is greater than or equal to 7. That's my first one. The other one is 3m plus 9 is less than 12. So if I subtract 9, I get 3m is less than 3. If I divide by 3, I get m is less than 1. That's the other one. So this is or. Want all the values that satisfy the first one or the second one or both. So m greater than or equal to 7. We want to include all of those values. Or the values at m less than 1. We want to include those. So any point that belongs to that graph, either piece of it, satisfies at least one of the inequalities. Okay. Well, we covered a lot of ground there, and I hope you do well at this. Here's a little journal assignment to prove you know what's going on. Take care. See you next time.